Awesome. Good morning or good evening to all, and welcome to the Data Driven Community virtual meeting. My name is Ronen Arieli, and I'm honored to host this meeting today. It's a great opportunity to remind about our next meetings. On March 23, we will meet online to speak about the daily routine of hybrid DBA, very interesting topic. And on March 30, we will have a meeting about migrating SQL Server on premises to Azure Managed Instance. You are welcome to follow the data-driven social media networks on LinkedIn, Facebook, Twitter, Eventbrite, YouTube, and the Meetup group as well. We are all over. If you want to present in one of the future meetings, then please contact Jen Joseph. You have the link of the email here, and after the meeting, we will upload the recording so you can download and use the QR as well. As at this point, please turn off your camera and microphone. If you have any question or just comment, then please use the chat. Today we are hosting Warner Chaves. Warner is a SQL Server Microsoft Certified Master. The short name is MCM. And the Data Platform MVP and Principal Consultant. Warner, can you share your screen, take the control, and maybe tell us a bit more about yourself?
Excellent. So let's get going. Thanks, Ronan. And let me share. And hopefully everything's good. Share. Hide. All right. So let's rock and roll. And I'll talk a little bit in the next minute here where we're going to the bio. But first, I want to welcome you all at Warehousing for the Masses. This is bringing data. I should change the title really because it's more about than warehousing at this point. I need to call it more like analytics for the masses or just massive data for the masses. Um, Thanks a lot for joining. It's wherever you might be in the world. Obviously, you could have been doing anything else, but you decided to join here for 1 hour to learn with me. So I appreciate that. Who am I? Been a DBA for a long time and a consultant for almost as long, 16 years now in the IT industry. I used to work out of Hewlett Packard in Costa Rica. I recently also changed my title from principal consultant to solutions architect at Pythian. I am honored to be a Microsoft Data Platform VP. I am on Twitter. If you want to reach out to me there, you can check out my personal blog at createdatapros.com, or my employer's blog as well, pythian.com. I have content there, and there's content from other things and everything related to data in general. Also, feel free to look me up by name on LinkedIn. There's only one Warner Chavez that looks like me, and connect. I love connecting with all the people that attend my sessions and learn from my material as well. So the agenda, first of all, I want to talk about very briefly, is about how cloud services disrupting the on-premises data warehouse or big data type of projects, and which ones are the popular offerings from the biggest providers. So this is why it's called warehousing for the masses, or I should change the name, like I said, to like massive data for the masses or something like that, because the whole value proposition here is that doing these type of projects on premises before was so expensive that only some select big companies were able to afford them. And now the barrier of entry has lowered so much that many small, medium-sized businesses can now afford to try to, compete and disrupt and improve their businesses by using data, just like the big guys have been able to do for a long time. All right. And in order to do that, usually, you use one of the big cloud service providers or platforms that, bundle all this capability. So I'm going to briefly cover each one of them. It's not a deep dive session into each a specific one because we would obviously run out of time. It's also not a deep dive session into one of them. You could do one session just dedicated to each one of these. Instead, what I decided to do with this session is to give everybody a kind of like a 10,000-foot view of each one of them, and then we're gonna do demos. I have demo environments of almost all of this. I The only one I couldn't get up and running in time was my Redshift environment because I haven't used Redshift in a while. So, but the other ones I have them there and we'll be able to see almost all of them. All right. So, first is, why is it important to learn this stuff, in my opinion, if you're in the data and IT industry, especially obviously if you're in the data space, right? So the history of on-prem to cloud to me is because the cloud brings a huge difference to how analytics or big data projects were done compared to on-prem, right? On premises, it was a big cost up front. You had to buy, it used to be, if you were doing big data or analytics stuff pre Hadoop, pre Spark, you had to buy something from a vendor, right? That's how Teradata became such a huge company. IBM sold tons of money with Netezza. Oracle obviously is still a giant in this space. Microsoft, there's a lot of people that use SQL Server using Column Store for data warehousing and all this. But all of it pretty much require big cost upfront. Even if you were a big adopter of some of the open source systems that open this to, not to be proprietary software. So let's say Spark, you still had to run Spark somewhere, right? So I have customers, or I've done projects where the customers finally migrated things that they built on-prem, 40 node, 100 node Spark clusters off to the cloud, to one of the platforms that we're going to look at. Huge savings in infrastructure maintenance, having to maintain, update, patch, et cetera, et cetera. It's a lot of cost to do this on premises. And you have to be very accurate about your forecast, right? I need this much capacity because you need it on-prem, right? You need the infra expertise. Like I said, it's either expensive appliances or you would need to have the expertise to run these really big clusters, right? And it's just longer development cycle, of course, right? Because you have to go through procurement, get everything in, configure, start learning, etc. In the cloud, we switch that model, right? Instead of a big cost up front, it's on ongoing cost. Instead of having to be super accurate about your forecasts, you have elastic capacity, so you can consume more. If a month is busy, consume less in another month. You don't have to get it really right off the bat because you can adjust it, right? You don't need the infrastructure expertise because all of that is managed. So all the services that we're going to look at today, they're all fully managed. You don't need to know anything about the hardware that is running on. And the development can be more agile, right? In the cloud, usually there's templates for creating and destroying things. You could, let's say you have an idea, you could use any of the platforms that you have today, maybe just run with them for a month or two. You decide, no, this is going nowhere, then you shut everything down, you're not spending any more money. Imagine on-prem, right? Oh, I think we should do like a big data experiment on something. Let's start our big VM cluster. Let's create 100 nodes of Spark. Let's run all this. 2 months later, it's like, oh, we don't need any of that actually. Like it didn't go well. Like, now you're stuck with all that stuff. So again, to me, this is what the cloud really brings a huge difference in how we run these projects. And the end result is the data warehousing and big data. And more importantly, what the users care about, which is business intelligence, data analytics, machine learning, all this stuff that is enabled by curating, collecting, modeling large amounts of data, it now has a significantly lower barrier of entry. There's going to be more companies doing it, and that's where everybody in this call comes in. I am a huge believer that there's a lot of untapped potential in this space for everybody to enter and to build great careers in this particular area of the data industry. Oh, sorry. So let's check out the cloud offerings in detail. Okay. So first, some common traits of all these cloud offerings. They mostly rely on multiple nodes. So these are all systems that work with multiple nodes in parallel. They're not SMP systems, okay? And an SMP system will be something like a big SQL Server machine, right? Instead of just being one massive machine, let's say each machine has like 2 terabytes, 128 cores, all this kind of crazy stuff. Super beefy machines you can buy today. Instead of doing that, then you have smaller but multiple machines, right? And the idea is that as you add multiple nodes, hopefully the system can scale linearly, right? So this is all of the systems that we're talking today are multiple node MPP systems, right? Multi-parallel processing. They all take advantage of compression algorithms too, whether you're using Spark and you use Parquet files, right? Or you're using some of the native stuff and like Synapse or Snowflake, they all take advantage of compression to process data better. Also, they don't enforce primary keys, foreign keys. This is a very common thing. People come from on-prem SMP systems and they're used to enforcing everything at the database engine level. And this is not something that happens at the database engine level. If you want to worry about this, there's different techniques that you can do. You can either check when you're loading, or you can just load everything and then run tests after to make sure that you're not logically violating these constraints, but the systems themselves um, don't try to do it. All right. They can be used as direct query sources or as backends for analytical tools and OLAP. So as I mentioned, this is the whole idea of these systems. They enable this type of capabilities, and they're tightly integrated with their cloud ecosystems, right? So if you run, let's say Redshift is tightly integrated with AWS. If you run Synapse, it's tightly integrated with Azure. If you run Snowflake or Databricks, for example, then Snowflake and Databricks are integrated, tightly integrated with all three of them, right? Like Snowflake can use S3, Azure Blob Storage, Google Cloud Storage. Same as Databricks, right? Um, because they are multi-cloud platforms, right? So these are the two that stand out as the biggest multi-cloud data platforms right now in the market, Snowflake and Databricks. Okay. So let's talk a little bit about, so we're gonna run through them now. So we're gonna start with Redshift, and I think we're gonna finish with Databricks, and we'll look at all the other ones in between, all right? So Redshift, it works again by doing a deployment of clusters. You can have multiple Redshift clusters in your AWS account. The clusters will have a certain amount of nodes, and the nodes have a certain amount of capacity, right? Redshift starts, Redshift, I think Redshift was released by Amazon around 2016, I want to say. So maybe it's about 7 years old. And Amazon took the PostgreSQL engine and customized it, give it MPP capabilities, and added a lot of the columnar storage stuff. And they've been kept improving on it since then. And you can really touch your clusters in a way that it's very customizable with how many cores, the memory, whether you want them to have hard drives or SSD drives and all that stuff. And you pay per node per hour. So the hardware of the nodes, the amount of nodes, all these are variables. And there's two versions of Redshift. There's a V1, version 1 of Redshift. That's what came out in 2016. And then about 2 years ago, Amazon released what they call the RA3 type, which is, I don't know what they couldn't just call it V2, but that's what it's called. And it's slightly different architecture of Redshift. And I'm going to show it in a sec here. So the Redshift V1 architecture was you would have a cluster, and you have very similar to like Spark, if somebody's familiar with Spark. You have a leader node, and then you have a bunch of compute nodes. But the biggest difference on the V1 of Redshift is that the compute nodes had to have the storage in that compute node. So a big limitation of the V1 of Redshift was that if you wanted to have a cluster with more storage, you had to add more compute nodes. Or if you wanted to have a cluster with more compute, you had to add more more nodes, and that would give you more storage, and you were still paying for more storage, even though maybe you were not using that extra storage, right? So um, that was V1 architecture of Redshift, and it had that really tightly coupled architecture, right? Compute was tightly coupled to the storage, and it's understandable. Redshift was the first data warehouse as a service offering in the cloud. And that's why I think it came out like that, very similar to the architecture that back then you would find on-prem with Hadoop or Spark, but it was quickly surpassed by other platforms that were designed to decouple compute and storage. So then Amazon came out with this other architecture a couple of years ago, that is the RA3 architecture that decoupled this, right? So if you see here, right, before we had the compute nodes with the storage. So the leader node and compute node concept is still there, but what happened is they decoupled the storage from the nodes. So now what they said, well, the nodes are going to have some cache layers, but the actual storage is going to be in S3, right? And we're going to have a layer of workers here, we call here Redshift Spectrum. And this layer of workers is basically you query a table and they know how to go in and find the particular files in S3 that are part of this table, right? So they decouple the compute and storage of of the Redshift architecture by using S3 and developing this extra layer of of let's say glue that allows the compute nodes to go find the files that they need for the tables in S3, right? So and this is the popular architecture. If you would do Redshift today, most likely you would pick the RA3 architecture and work with this. All right. And if you are big in AWS, basically the biggest two choices that you have is either to go with Redshift or to go with Snowflake. And we'll talk about Snowflake in a little bit as well. Okay. Now, this is another one that's very popular is Google's BigQuery. All right. So BigQuery is serverless. So that's a big difference from Redshift, for example. Redshift, you deploy clusters, you pick the nodes and whatnot. BigQuery, it's 100% serverless. You load data and then you query it, and you do not have to deploy nodes, clusters, or anything. It is interactive SQL querying, and it's a relational schema, so you still have to build tables and columns and whatnot. And it's done. Google does columnar storage behind the scenes, what they call the capacitor engine. And this columnar storage is similar to what if you're familiar with SQL Server, it would be like column stores kind of thing. So it's highly compressed, and it only has to process the columns that are part of the actual query, right? Now, BigQuery does have a big difference is that the insert, update, delete statements, when BigQuery released first, it didn't even allow you to do insert, update, or delete. And then obviously, eventually they had to allow it, but they still have, even to today, they have some limits. I think you can only run up to a certain amount of insert, update, or deletes per day. And then after you hit that limit, basically the system like queues them up, and then they will run again like the next day and stuff like that. So it has some limits. If you have a warehouse that is dependent on doing a lot of like um, update deletes, that is not just append, then the BigQuery might be a limitation for you, or you'll have to change the way that you do things and focus more on the just appending. And notice that I said the insert. So obviously you have to insert data to load, but BigQuery has like its own batch commands and streaming commands. So as long as you use the batch commands and the streaming commands, then that doesn't have a limit. But if you literally type like insert into in like the console, that's the kind of like one-time insert. Those are the ones that have some limits because the system is just not built for that type of like really small modifications, right? Partitioning is supported by BigQuery, as well as key clustering. Key clustering means that you pick a column and then BigQuery sorts the data and in like the storage layer by that column. You pay for storage, you pay for streaming inserts, depending on how many you do per day. But the biggest way or the simplest way to look at it, and biggest driver of cost of BigQuery is you pay $5 per uncompressed terabyte that you read per query, right? $5, that's it, per terabyte. If you don't, if you read, 10 terabytes in a month of data in your BigQuery queries, then you'll pay $50, and that's it, right? So this doesn't sound like a lot, but it's kind of tricky too. Um, because if you are, giving access to BigQuery to a large amount of people and it's kind of unpredictable how much data all these people are going to try to query, and somebody goes in and does like, some big queries every day, like it adds up, right? So it doesn't sound like a lot up front, but it doesn't mean that you can just forget about it. You kind of have to like get a feel also, because the cost is variable, right? You don't know exactly what your bill is going to be by the end of the month. Google has some good tools to forecast the cost though, so it'll tell you, well, if you continue going the same way, then your bill is going to be this much at the end of the month, right? So you have a way to try to anticipate a big bill, but at the end of the day, it is the variable bill, right? You can switch to flat rate pricing, but that will be more expensive upfront, right? They have larger minimums for flat rate pricing, and that might be good, might not be good for you, depending on how you use the service, all right? It does have a way to increase compute power. As I mentioned, it is serverless, right? So you don't say how many nodes you need or how many cores or anything like that. But if you run a query and you find that it's too slow, it has a mechanism that allows you to say, well, like for the next 1 hour, 2 hours, I want to have more compute power than the usual because I really need to run this query and make it go faster. I forget what the name is called. It's something like reservations or something like that. So that's BigQuery. And this is Google's premier data engine. Almost everything in Google Cloud has an integration to put the data into BigQueries. And the Google Analytics, for example, you can integrate into BigQuery. The Google billing information from Google Cloud, with a couple of clicks, you can get it to load into BigQuery. Google Metrics from logging on Google Cloud, same thing. You can just easily integrate it and Google will load it into BigQuery for you and so on. So, you know, Google has invested a lot in BigQuery, I guess is my point. All right. It's a really good product. So the BigQuery architecture, so these are all shared virtual resources, right? Because it's serverless. So it's not like you get this dedicated just to you, right? A Redshift cluster is just yours. It runs in some machine that's probably being used by somebody else, but the actual resources of the cluster are just yours. In BigQuery, these are shared virtual resources, right? And they have a really massive storage layer where all your data is sitting. And then when you run a query, then there's code there that will go and find the different shards, the different fragments of that table from the storage layer. And then they run into what they're called mixers. And depending on the complexity of the query, then the system automatically says, okay, well, let's start with like 3 mixers to do the first layer of the query and so on until you get to the top of the query, right? The last final mixer that grabs the last, the results from the other level and throws it back to, the user, right? So that's how BigQuery works. It's very massively parallel and you don't have any control over this particular piece, right? It's serverless, it's all shared. All right, now let's talk about Synapse. So everybody that's familiar here with the Microsoft space, obviously I'm a Microsoft MVP. So I've used Synapse quite a bit. And Synapse is a very, very interesting product that stands out from the other ones in a couple of different ways. So Synapse is not just the SQL engine, right? It has a SQL cluster service, similar to how Redshift would be. And Microsoft called this the dedicated pool, but it also has a serverless component that queries against Azure Data Lake files. Okay, so it has kind of like a mix there. We said Redshift is you have some clusters, BigQuery is completely serverless. Well, in Synapse, you have the cluster service, which is the dedicated pool, and you also have the serverless option that also charges $5 per terabyte, by the way, against the data lake. Now, the limit here for the serverless part of Synapse is that it is only for querying. It is only for doing select statements. And if you want to change the data, you have to rematerialize it. Like you have to say, you have table A and you want to change it in some way, then you have to basically create, a new table, A point, AV2 basically, and just change the data and write it brand new table, right? Because it does not do any DML. It doesn't do insert, update, delete at all, right? So that's a big difference in functionality from the serverless in Synapse than from the one in BigQuery. Another thing that's different about Synapse is that Microsoft really added a lot of stuff into it. So Spark is also inside Synapse in the same environment. The dedicated pools, they use premium storage. Usually it's not a 1 terabyte minimum, but you get charged to 1 terabyte. Um, if you load less, then you just load less. The dedicated pools, you pay depending on the DWU, which is the amount of compute nodes that you need. You can batch load through Polybase. Polybase is also in SQL servers. It's the technology that allows you to really read data in parallel really fast. Or you can just run inserts on T-SQL. And there's no limit to that, right? So unlike BigQuery, you can just run inserts all day if you want, and that's fine. But again, BigQuery serverless, in Synapse, you have to have your dedicated pool up and running. An advantage of Synapse, though, is that it is decoupled, the compute and the storage, right? So you can add more and more and more data to the dedicated pool and keep the compute low, or the other way, you can increase a lot of the compute even if your storage doesn't change, right? And the other thing about Synapse that's nice is that compute can be moved up and down in a short time. However, to do that, the dedicated pool cluster goes down. So um, the pool shuts down, it resizes, and then it comes back up. Whether you move it up or down, same thing. The pool will shut down, resize, and come back up, right? And this is that Synapse dedicated pool architecture. So the way it works is that Microsoft takes your data and then it has this thing called distributions at the storage layer. And the distributions, there's 60 distributions in a dedicated pool. They take that data. So let's say you have, to make it easy, let's say you have 60 million records, then each distribution will hold 1 million records, right? And then you have a certain amount of compute nodes that connect to these distributions, right? So if you have one node, for example, then that one node will be connected to the 60 distributions. If you had two nodes, then now one node will be connected to 30 distributions and the other one to other 30. If you have three nodes, then now, each node is connected to 20 distributions and so on, right? That's how it works. And then there's a control node at the very top, similar to the leader node for Redshift or, the mixer 0 for BigQuery, which is the one that aggregates all the data at the very end and brings back the results for the end user. All right. So that's Synapse. That is the dedicated pool architecture. I didn't add everything inside Synapse because Synapse is a huge product and the session will be super long. But this is just the dedicated pool architecture. Then there's also the serverless, there's the Spark, and there's the pipelines and everything. And we're just about to go into the first demo break here. There we go, demo break. So I can jump in and we can look at some of these tools now. So I'm gonna start. So far we talked about Redshift, BigQuery, and Synapse. So let's do BigQuery and Synapse right now. So I'm gonna walk through each one of these and some of their major features. As I mentioned before, Synapse, one of the biggest things is that it has more than one engine, right? So you see here mine right now. I have the serverless. The serverless is always online because you don't control it. It's just Microsoft's own hardware, and you can use it whenever you need it. And then I have the dedicated pool right now. You can see here it's paused for me. I don't have it up and running right now, but if I wanted to, I could have it up and running. And the config on mine is what is called DW100C, which is the starting level of Synapse. It's just one node. And you can see here the max size is 240 terabytes, which is a lot of data, especially when it's compressed, right? This is compressed. So 240 terabytes means you can probably have almost a petabyte, if not a little bit more, inside one of these Synapse clusters, right? And then it not just has the SQL capabilities, it also has Spark as part of these capabilities as well. You can see here I have a Spark as well in this environment. I can create another one if I wanted to. There's a big difference here. We're going to see it later between the Spark in Synapse and the Spark in Databricks, but I'm going to show it now. I'll remind you later. And it is that Synapse, it's very simple. It's like t-shirt sizes, right? So you can see here, when you deploy Spark inside Synapse, it's from small to double extra large. That means from um, 4 vCore nodes to 64 vCore nodes. And then you pick how many nodes you want, right? So you see here, you can go all the way to, I think it's 200. Yeah, 200 nodes, right? That's a lot, right? Imagine if you do the math, If you pick the largest amount of node, 64 vcores, multiply it by 200, and you get all more than 1,000 cores if you wanted to. I actually don't think it will let me do that. If you try to do that, it'll say to call support to make sure that you really need what you're trying to do. So I won't even let you do that. But it is possible if you call support and you tell them, hey, I really need this. They'll charge you for it, but it's very expensive, obviously. All right, so I'm gonna discard this. I'm gonna show you something else because the thing about Synapse is that it's not just a SQL engine as well either, but it has a really rich development environment. So you can have SQL scripts, for example. See, and I have a nice editor here of SQL code, and you can also have notebooks at the same time. So for example, I can open this. And you see here, I have created a Spark database, uh, set the database and run all this. This is a fully interactive Spark notebook. I can run it, get results, everything, right? I can use Markdown. So it allows you to do a bunch of things in the same environment. Something that's really cool about this too is that it's kind of like browser. So I can open multiple tabs. So I can have a SQL script in one side and a Spark notebook in the other, and they all run in parallel, which I really like um, compared to some of the other offerings, right? So and then even that it has even more stuff than that. If you want to actually develop data flows, for example, you can do that inside Synapse as well. If you're not familiar with data flows is like the transformation engine in Azure Data Factory or Synapse pipelines, right? So it's a low code transformation engine. So instead of having to code this stuff in a notebook or coding it in Python or something like that, you can just do it in a low code way by adding different steps. So you can say, for example, here I'm importing data from a table, from a SQL table. I'm importing data from a file in storage, and then I'm doing a lookup. I'm removing some columns I don't need, and so on, right? And I do this all just by configuring the GUI and not having to write code to do it. Now, if you're like a super power user data engineer, this is probably not for you because you probably would just want to write the code and be done with it. But if you're just a data pro and you want to do some transformations and you don't want to have to, learn a new programming language from scratch or whatever, then you can use the low code approach. But my point here is that, again, you can have all this different type of functionality all in the same development environment, which I think is really cool. So you can have even the pipelines here. I'll show you again. Here I have a Synapse pipeline, right? So the whole pipeline engine that Microsoft developed for Azure Data Factory, they also put it inside Synapse and they fully integrated everything between the pipelines engine to the Spark piece to the SQL piece as well, right? And here, when you run SQL scripts, then you can decide who are you running it against, right? Either against a dedicated pool, show you right here, so you decide whether you run it against a dedicated pool. Mine right now, I can't run it against the pool because it's not online, right? So it shows gray. Or if you're gonna run the script against the built-in serverless, in case it's just like a select statement that you're running against data lake, then you can run it against the serverless, right? So very cool integration of different stuff that Microsoft did inside Synapse. Now I'm gonna show BigQuery next because we did talk about BigQuery. And then there's a couple of cool things about BigQuery. So first, BigQuery has a lot of also built-in capabilities. It has the SQL workspace, which is this environment where you can just run queries and get results. It has data transfers, and this is what I mentioned when Google, it builds a lot of integrations to BigQuery, like Google Analytics, the Google Metrics, Google Storage. You can transfer a lot of different things into BigQuery. You have the ability of doing scheduled queries. So these are just like literally what the name says, right? The BigQuery can run some queries on fixed schedule. You have the Analytics Hub. Analytics Hub is Google's product to share and collaborate with data sets. Dataform is another product that Google has developed to do transformations inside BigQuery. So there's a lot of different functionality as well that is Google has built into the BigQuery ecosystem too. Um, something that I really like about BigQuery, I have to say, is that Google has a lot of external um, open data sets. And because of the way that BigQuery works, that is all serverless, you don't have to pay for the storage of those data sets. So I'm going to show you right now here. For example, I have my environment here and I am connected to the BigQuery public data set, and it has all these different data sets. Look how much stuff there is in there, and I don't think I even get to the, I'm not gonna get to the bottom of it. Yeah, so there stuff there from, major cities in the US that have open data standards. So like New York City, for example, there's like taxi information, demographic information, crime related information, flight information, there's COVID information, there's Google's own information like about past Google keyword trends and all that stuff. There's about sports. There's data sets about baseball. There's data sets about FIFA. Um, what else? There's blockchain data sets. So if you want to read a BigQuery data set of all the Bitcoin transactions, all the Ethereum transactions, there's so much stuff here. And this is literally hundreds of terabytes of storage that you don't have to pay for just to query them. All you have to pay for is the compute, right? It was $5 per terabyte. So you guys can see here, for example, I have this here on the screen. It's a really quick, very simple query. It says in the BigQuery public data, there's a data set called Google Trends, and there's a table called International Top Terms. And I just figured out here, it says, I put a couple of predicates. So it says where the country name is Argentina, find some really popular terms. So the rank is less than 5, and I wanted to get what was popular during 2020 and limited by 10. So it gave me different terms that were number one in Argentina during 2020. And unsurprisingly, almost all of it is related to football or soccer, depending on where you are in the world, right? It's all like Boca Juniors is football, Juventus is football, Barcelona is another football game, Real Madrid is football, River Plate is football. So obviously, the Argentinians really like their football, but really cool, right? Like all this stuff is available for experimentation and for you to, like, if you want to brush up your SQL skills on really big data sets, or you want to do some of your own citizen analytics, or you want to do ML or whatever on these data sets. Really cool because you don't have to move the data over to your account and pay for all this storage. You just have to pay for the compute. And it gives you an estimate of how much you're going to compute to, which is really cool. See what it says here right at the top. It says this query will process 8.18 gigabytes when it runs. So if the Google engine can estimate how much data you will consume, then it will give you the number there at the top so that, you're not afraid to run it, right? So let's say it's $5 per terabyte and you don't know if a query is going to consume, 20 terabytes, suddenly that's, $100. You don't want to spend $100. So it actually gives you an estimate here. Oh, this is going to process 8 gigs when it runs. Oh, sweet, whatever. It's going to be a few cents. Boom, you can run it, right? So this is some of the things that I really like about BigQuery. All right, we still have 2 more engines to go. So let's keep going with the material. And we'll have another demo break when we're done with the next two. So Snowflake is going to be the next one. I'm a huge fan of Snowflake. I have to admit, it is probably one of my most favorite products that have been released in this space in the last few years. Things I like about Snowflake, it has this concept of virtual warehouses. So the compute is clusters. They call the clusters virtual warehouses, but you can deploy a bunch of different ones in your Snowflake environment, and they're all pausable. So you can shut them down, or they can even go to sleep on their own. And then let's say, for example, you have marketing and finance using Snowflake, you can create a little warehouse. Let's say finance almost never uses it. You can create a little warehouse, just one node for finance. And let's say marketing has like really big reports or something like that, you can make a bigger warehouse just for marketing, and then you can At the end of the month, you can see exactly how much money was spent for finance, how much was spent for marketing. So I think that's really cool. Snowflake also supports SQL. They have their own SQL dialect, very similar to T-SQL as well, and to PLSQL. You can do store procs in JavaScript, or they also developed this thing called Snowpark that sounds similar to Spark. That's because it's supposed to, and it's basically they took the data frame, Python, Scala, Java languages that you would be used to doing in Spark, and they made it run inside Snowflake, and that's what it's called, Snowpark. Snowflake is multi-cloud, so it runs in AWS, GCP, and Azure. You pay on variable compute, so similar to BigQuery. You don't know exactly how much you're going to spend every month, because the virtual warehouses go to sleep when they're not being used, and then they wake up when somebody connects to them. So the compute can go up or down. You don't really know exactly how much you're going to spend, but it has ways to control it. So there's a thing called resource monitors, and you can say, I don't want to spend more than this amount of money. And if this amount of money we get to it, then you have the option to either just send an alert to an operator, or you can shut it down completely and just be like, that's it. That warehouse doesn't come back up until next month, right? It can do batch loading, serverless. It can do micro batching. So it has a service called Snowpipe. Then you just say, hey, Snowpipe, you have to listen to this folder. And in this folder where new files arrive, then automatically the servers will start loading them. And I mean micro batching because you can set Snowpipe to load as frequently as every minute, right? So that's pretty frequent. If you wanted to do something like near real time, as long as you can continue to deliver files, a new file every minute, then Snowpipe will be able to keep up with you. And they're working on having streaming endpoints as well now in Snowpipe. That is in preview right now. It's not there yet. Compute and storage scale independently in Snowflake. As I mentioned, you have multiple virtual warehouses. Compute moves up and down in a short time, and an advantage of Snowflake is that when you resize, it's an online operation actually. So it's pretty cool. So this is a downside of Synapse is I want to resize my dedicated pool. It goes down, it resizes, it comes back up. On Snowflake, you can have queries running and you resize it, and the queries don't get canceled or anything. It's just the queries that already started are not going to use the extra resources if you are adding resources, but they're also not going to get killed, right? And then after the resize is done, the new queries that come in will immediately start using the new resources. So that's really cool. It is an online operation to resize the virtual warehouses. And it includes kind of an interactive environment similar um, to the SQL editor. We'll see it in a minute. And it's called the worksheets. And you can build some simple dashboards with a Snowflake as well. It has that built-in capability to just do some simple dashboarding inside Snowflake and to share them with other people. Okay. So the Snowflake architecture, as I mentioned, is a cloud agnostic layer that Snowflake has written that is compatible today with Google Cloud, AWS, and Azure. It has the centralized storage inside Snowflake, like when you load into Snowflake. However, Snowflake can also connect to all the different cloud providers' cloud storage and query from them as well. So you can create external tables, for example. An external table can connect to an Azure Blob Storage folder, for example. Then it has this other ring where it says multi-cluster compute. That's the idea or the concept of those virtual warehouses. And then on top of the multi-cluster compute, it has this layer of cloud services, right? And these cloud services are the ones that do query optimization. They do the management of the system. They coordinate transactions. They manage the security and the governance. They keep track of the metadata. This is something that's very cool about Snowflake. The metadata lives in the cloud services layer. So if you want to explore your schema and like do like a describe of a table and look at the names of the columns and all this stuff, it doesn't even have to start a cluster, which is really, really neat, right? It's not like in Synapse. If I want to look at the schema of some of the tables that are inside the dedicated pool, I have to start that dedicated pool cluster, right? So it's a big difference. And it has sharing and collaboration capabilities as well for the data. You can share data sets really easy with Snowflake. And it has a marketplace where you can even buy and sell data sets too. All right. And the other one that has become very popular in the last few years is Databricks. And a lot of people ask me about Databricks too. Databricks is a proprietary customized Spark. And what Databricks does is that it creates Spark clusters and that allows you to pause compute as well. So you can set the clusters to go to sleep as well, and you can start the clusters when you need to start working on them too. And it is, again, built on top of Spark. So at the end of the day, it is the Spark engine, but Databricks has done a lot of work to make it faster, to add more capabilities to it, and so on, right? It is multi-cloud as well. So Databricks also runs on AWS, on Google, and on Azure. And they are also integrated with cloud storage, right? So it'll run against S3, Azure Blob Storage, Azure Data Lake, Google Cloud Storage. You can scale independently the compute and the storage, right? Because the compute is all Spark clusters and the storage is all cloud storage. The clusters have lots of configuration. I'm going to show you that in a second. If you guys remember, just a few minutes ago, we saw the Synapse, and in Synapse is just t-shirt sizes for the nodes, right? The small to extra large. In Databricks is a huge menu, which might be a pro for some people. It might actually be a con for some people. Some people might like that. Some people might not want to deal with the added complexity of so much configuration. Supports all the languages supported by Spark, and Databricks also supports notebooks, and it has machine learning modules already built into it, and it has some simple dashboarding capabilities built into it as well. All right, so here's the Databricks architecture as well. So Databricks has a control plane that they have that they deploy themselves into all of their cloud providers. And then they also have the data plane. The data plane is the actual part that they put inside the customer's network. In Azure, for example, when you deploy Databricks, you have to select the virtual network where Databricks is going to go. And this is where this data plane goes into. All right. And then you can have some of the Databricks what they call the Databricks file system is a layer of storage that the nodes can connect to. But at the end of the day, what they use for the actual storage is S3 or in Azure Blob Storage. And this diagram doesn't have Google Cloud, but it is GCS for Google Cloud as well, right? And then Databricks integrates same thing. With you want to do SSO with either the AWS directory or with Azure AD and so on. So Databricks takes those capabilities that are missing from the vanilla, let's say vanilla Spark, right? And then they add on them. Databricks is only in the cloud. You cannot run, like you can't download Databricks and install it on premises, okay? Same as Snowflake. Both Databricks and Snowflake, 100% cloud solutions. All right, now let's do our last demo break for today, just to show you real quick here, Snowflake and Databricks. So this is Snowflake. So you see here this concept of the worksheets that Snowflake has. I can go here. You see I have some basic select examples. Snowflake has a really neat um, interactive GUI. When you run it, it gives you a profile of the data itself. You see here, for example, this is reviews. So like a reviews website, for example, where users review businesses. And you see I have this stars column. So you can click on it, for example, and you see it tells me the distribution of the values for the stars, right? So 1 to 5. So these are all the have 1, 2, 3, and this is all interactive. So if I wanna just so it really helps with exploration of the data. If I want to just see right away the records with stars 5, you can just go ahead and um, see how many there are here by clicking on it. Hey? And if you go here, you can see the grid itself as well. You can sort, resort, you can increase decimal precisions, you can decrease decimal precisions, and so on, right? So I think that's pretty cool. Um, it also gives you, how do you go back here? Uh, close. All right, there we go. Change to another value. Let me rerun this one. All right. It also gives you here the query details as well, right? So you can see the warehouse that was used, who run it, the time, and you can even see the query profile. The query profile is basically like the execution plan in Snowflake as well. You can see here this particular one. This is another cool thing about Snowflake. This execution plan says query result reuse because Snowflake has a persistent cache layer. So because at the beginning of the demo, I went in and I ran it, that was the first time, right? And then when I wanted to get back to this homepage, I ran it again. Then the second time I ran it, it just grabbed the results from the cache. It didn't actually go and look up the files and the data and did the compute again. And it is automatic, by the way. If I was to do a change to this reviews table, for example, like I would add a few records to it, then the next time I run the query, Snowflake will be smart enough to not give me the results from the cache. It would just go and grab them back again from the files. So I think that's pretty cool. Um, I want to show you as well here the interface of the Snowflake portal. It keeps track of all the query history, the copy history, tasks. Tasks are like the jobs inside Snowflake. The warehouses, as I mentioned before, you can add. I have two warehouses here. One that I call the compute, that's just for running queries normally. Another one's called data load for loading data. And you can add more, right? Like I said, you can have one for marketing, finance, anything. And the way the warehouses work, let me go back and edit it so you can see here. Warehouses are sized t-shirt size as well. So this part is similar to how Microsoft sizes the Spark piece. So they go from extra small, which is 1 credit per hour, which basically means 1 node, right? Small is 2 nodes, medium is 4 nodes, and so on. Goes all the way to 4 extra large here in, I think this is Azure where I have mine running, which will be 128 nodes. All right. And then the nice thing about these, like I said, is that they all bill independently. They can go to sleep and wake up independently. If you see here, it says auto resume is on, auto suspend is on. They will suspend after 5 minutes, and they will auto resume too. So once it's fallen asleep, if somebody connects to it and just runs a query, it will automatically wake up. So this is really nice because it doesn't mean like, oh, it goes to sleep automatically. But when you want to start it, somebody's got to go in the portal and press like start. Hey, we want to use you again, right? Because it's easy to go to sleep when there's no activity, but it's harder to have it wake up automatically when you connect to it, right? It's a capability that some of the other providers don't have, right? Let me sign in here to Databricks. All right, so this is Databricks. Databricks has a little bit more in it because Databricks also goes a lot after the machine learning space. So this is a part like if you were using Synapse, you would do the Azure Machine Learning Services, for example. BigQuery has some ML built into it, but you can also use Google Clouds, Vertex AI, AWS has SageMaker. Snowflake is partnered with Snowflake can use all of these that I just mentioned. SageMaker, it's Azure Machine Learning, but they also use a lot of their third-party ecosystem partners like H2O or DataIQ and all these other tools, Alteryx, etc. But Databricks actually puts an experience for ML right in the interface. So you see here, I switched the role that I'm trying to use Databricks as, right? From data science and engineering is basically really focused on the notebooks, right? So I have some notebooks here. You can open a notebook and it gives you the classic notebook experience, right? Some cells with code, some cells with output. Um, but you can switch to the machine learning side and then it changes here the things that you get from the interface right here. Now you have experiments, so I've ran some experiments that you have one there. So you see here there's this experiment here, you can open it and it'll bring you into um, the experiment tracking. So it shows you, you know, what is it that you were trying to do, the algorithm that you did, and then you can actually click on it and it'll tell you, you know, the parameters that were used and what the results were. And it has all this stuff is usually, for example, you can run it again if you wanted to. Um, this will be the kind of stuff that in Azure you would get from like Azure ML, right? It's not like bundled right into Synapse, but it's all bundled in here with Databricks. You have your different models. You can see if it's a staging. You can separate a model that is in staging from one that is in production, and so on. So this is a big difference from Databricks, is that it incorporates this ML stuff. Now, what I was gonna say before, just to show here that I did make a point about the options that Databricks gives you. So see, this is the creation of a cluster in Databricks, right? And you can see there's a bunch of different versions of Spark that you can run, a bunch of different versions of Spark that you can run, and there's a lot of different node types that you can pick from, right? I'm gonna scroll here so you can see how many there are, right? So there's a lot more customization in terms of your clusters that you can do in Databricks compared to what you can do in Synapse, for example. Now, that might be good for some people, that might not be good for some people, depends on what you are trying to do. All right, so just do a quick recap here as we wrap up the session. So, common deciding factors. How do you pick? Oh my God, so much choice here, right? So I think this is a bad thing to do. If it's just to say, well, I use AWS before, so I'm going to use Redshift, or I'm on Google, so I'll use BigQuery, or I'm on Azure, I'll use Synapse. You know, ideally, I think other deciding factors should come into play. For example, how do you want to try to provision and control things, right? Do you want a lot of config control like Redshift or Databricks? Do you want to just quickly go up or down like Synapse or Snowflake? Do you want to just be serverless completely, right? With BigQuery, BigQuery is fully serverless. Or are you okay with some of the limitations of the Synapse serverless, right? You have to analyze what you're trying to do. Same thing with the pricing model. Do you want it to be really predictable with, you could go with Redshift or you could go with Synapse if you want to know exactly how much you're going to spend every month, or if you're going to do something, do you want to do something variable, by either doing a Snowflake or Databricks or paying for compute, or if you want to go into a model where you pay by how much data you read, then you're looking at BigQuery or Synapse serverless. And again, how do you want to manage your cost depends on you. And then how much do you actually want to mess with the thing? Some of them have a lot of tunable options, like Redshift and Synapse have distribution keys. Almost all of them have the idea of sorting or clustering keys. Some of them have different types of indexes, like Synapse or Snowflake. Some of them you can put multiple indexes. And some of them have almost no options other than partitioning or clustering, like BigQuery. BigQuery is very, very, very plug and play. You can partition the table if you want to, you can cluster it if you want to, but even if you don't, BigQuery will do its best to just bring you back the results of your query regardless, right? It's more of an optimization thing. So that really depends. Do you want to be really like a in detail tuner, or do you want to just leave most of that complexity out, right? So it's up to you and what you are trying to do, or how much control you want to keep over the solution, and whether you have the expertise or not. You want to deal with it or not, right? So, recap, the cloud has drastically lowered the barrier of entry. I just showed you 4 of those platforms. I have them all. I use them all for demos and consulting and everything. I'm obviously not a, several $1 million enterprise IT budget that I have. I spend, less than a few $100 every year keeping all of these online for myself and for my demos and consulting work. Um, each provider has a different service. They all have different characteristics, but they're, if you learn one of them, I think it's not too difficult to learn pretty much all of them. And while it's easy to select just based on the provider, I think you can, try to be a little bit more detailed and think about your use case, how flexible is the service, what's the cost model that you like, and what are some of the things that you want to integrate it with to really get to the ideal choice of platform for you. But at the end of the day, really, my message is that this type of platform and project that would use these type of platforms is now available or at the hands of many more companies that were not able to afford this kind of thing before, and that opens up a career space and market potential for professionals like us to be able to offer this stuff to more and more and more organizations and companies, right? So, questions. Let me go back.
Okay, we have two questions. There is one that asks about the presentation. Will you share the presentation?
Yeah,
We
for
always
sure.
share recording. Okay, so you will need to send
I'll
me
just
the
email it to
presentation.
Ronan. Yeah.
The second question, it's a comment that multiple, he asked if multiple indexes on tables for Snowflake. You mentioned
Yeah.
it, maybe it was a mistake.
No, it's not. It's so it's what Snowflake does is it can create multiple indexes, but you don't manage them, right? So this is what I mean by the plug and play capability. Snowflake has this thing called a search optimization service. And so instead of you going in and creating, create index on this, create index on that, it's on the enterprise edition of Snowflake. You just say this table, turn on the search optimization service, and then Snowflake will take care of creating the indexes for you. And that's it. You don't do anything else, right? So it does allow you. So if you want to have multiple fields that need point lookups, you can go with Snowflake, but you won't be the one actually creating the indexes yourself, right? So that's a good point of clarification.
Okay, there are a few more questions that coming on the chat, so maybe you can just go over them.
What is let's see, if I use Synapse, can I get component-wise costing? Like this pipeline cost? Yes, yeah. So if you use Synapse, then the bill for Synapse is actually quite complicated. If you use everything, you'll get a charge for the dedicated pool, you get a charge for the serverless pool, you get a charge for the pipelines, you'll get a charge for what else am I missing? Spark. There's a lot. So there's a lot of different parts of the Synapse bill. Um, I do believe that you do get a bill item specifically for a pipeline. So if you are running it using the cloud runtime, so basically the Microsoft Cloud compute for your pipelines, then yes, you get charged by the pipeline. I don't know if it will just give you just one number for all the pipelines for the month, or if we'll actually break it down for you. It might be that it just gives you $1 number, but you could probably figure out which pipeline is the one that consumes the most using some of the other metadata, like how long it runs and stuff like that. But I don't know exactly if it really goes as like one little item on the bill. Probably not. For data engineering job, which cloud is in more demand? Well, so that's a great question too. So just going by market share, Amazon is still the biggest one, right? Amazon has more market share than all the other ones. The way that it goes is AWS has the biggest market share, Azure has the biggest market share, then Google has the biggest market share. And then there's also the market share of some of the multi-cloud platforms, right? Out of all those, Snowflake has a certain market share too, and Databricks have a certain market share too that is independent, right? Because they can run on all three of those cloud providers. So I guess all that to say is that, I think data engineering is in demand regardless of the cloud. So if you want to focus on it, I would just focus on being a really good data engineer in general, and not so much as I want to just be a data engineer on AWS because it's the most popular cloud. Also, if your company picks a certain cloud provider, then you probably want to be, really good at the cloud that your company selected, right? Parvis says, are the data warehouses offered by non-cloud providers like Snowflake or Databricks more expensive? It depends on what you use them for. It's really hard to compare apples to apples, right? Because let's say just basic comparison. You want to compare Synapse to Snowflake, and Snowflake runs on Azure. So you say, well, Snowflake runs on Azure, so Snowflake has to pay Azure, and then I pay Snowflake, so it must be more expensive. But it's not that easy to compare because Snowflake can go to sleep automatically and wake up automatically, for example, right? And Synapse doesn't have that capability. So will you spend more just because you're using Snowflake? It's not necessarily, right? So it will depend on your workload to really figure out um, if it will be more expensive or not for you, right? All right. Disadvantage of Synapse, I think, is that you need to distribute the data. Yes, exactly. That's the disadvantage of Synapse. Um, I guess it depends how you look at it too, right? If you really want to have big control of how your data is co-located, then you could say, well, I like because Synapse, I can pick specifically the distribution key. But for most people, probably the Snowflake or the BigQuery approach of just let the platform deal with that is probably better because they probably don't even have the actual expertise to make the best choice, right? All right, cool. I guess that's it for the questions today. Well, I appreciate everybody that joined. And yeah, I'll share the slides with Ronan. That's not a problem. And yeah, I assume that the group will share the recording once it's available too.
Yes, obviously. The recording we always share, so this will be announced once it's ready. I want to thank our speaker, Warner Chaves, for a great session. And thanks all of you for joining us today. Don't forget to follow us, and we will meet in our next activity of the Cloud Data Driven User Group. So see you next time.
Thanks, everybody.
Bye bye.